Okay, you're welcome. For the first question we are going to look at, they said, what is the parity of this particular cycle? So we have a disjoint cycle, and then we are asked to find the parity. And so, working for the parity is simple. If a cycle has an odd length, so for parity, we say that if a cycle has an odd length, so let's say parity, let me just write it in simple term. Parity is equals to if it is odd, -1. If it's so, this one odd and this one even. If the length is odd, the parity is -1, and if the length is even, then the parity is +1. So now if we take back our element that we have, which is a disjoint element, I think this is a disjoint element from a symmetric group of 8 elements. A disjoint cycle from a symmetric group of 8 elements. So we can say that it's 8 or something. Looking at the highest number in the cycle. So in that case, we can say that we have 1, 2, 1, 3, 4, 4, 5, 1, 5, 2, 5, 6, 8, like this. And so I already said if the number here is even, the parity is 1. So here the parity is 1. So we are multiplying times this one. There are 3. Yeah, the length of the cycle is 3, so that's odd, and the parity will be -1. This one too, that's 2, so the parity is 1. This one, the parity is -1, and finally the parity is -1. So let's start multiplying. 1 times -1, that's -1. -1 times 1, -1. -1 times -1, that's +1. +1 times -1, that's -1. So the parity is -1. That is all for this particular element up here. The parity is -1. Okay, so we come again to question 10, which says, what are the generators of Z8? Well, what do we mean by a generator? A generator is an element of any group which is able to generate back all the elements of the main group. So if we take Z8 has elements 0, 1, 2, 3, 4, 5, 6, 7, or 6, 7, that's all. The element itself is not part. Now, what will be a generator? Well, there's a shortcut for identifying what a generator is. If we consider these elements as key, and then if the GCD of k, and if we consider this as n, is equals to 1, then k is a generator, of the group with order n. Okay, so what does it mean? Well, just like we were talking about things that are relatively prime, it's the same thing we are saying here. So the greatest common denominator of the two numbers can only be 1. So if I take 8, well, then 8 and 1 doesn't have anything in common except 1. So 1 is the first generator. 2 cannot be a generator because there's a common factor, because 2 itself is a factor of 8. So 2 cannot be a generator. 3, yes, 3 is a generator. 4 cannot be a generator. 5 has to be a generator. 6 cannot be a generator, and 7 has to be a generator. So the generators of Z8 are 1, 3, 5, and 7. And they are 4. Each of these, if we want, we can test to see whether actually is a generator. So for instance, if I take maybe 3, if I take 3, so adding 3 to 0, or 3 itself is the first element. If I add 3 again and take mode 8, that's 6. If I add 3 again, and that will be 9, mode 8, that's 1. If I add 3 again, that's 4. So 4 mode 8 is still 4. If I add 3 again, mode 8, that's 7. 7 mode 8 is still 7. If I add 3 again, that's 10. 10 mode 8, that's 2. If I add 3 again, that's 5. 5 mode 8, that is still 5. Now if I add 3 again, that is 8. And 8 mode 8 is 0. So let's see. If you compare this group and the original group that we have here, they all have the same element. So that is why we are saying that 3 is a generator of the group Z8. Is that okay? So likewise, if you take 5 or 7 or any of them, you are still going to be able to generate all the elements of the group. And so on this note, my pen is going battery low. I will stop here. Kindly subscribe. We'll meet again. I'll look at the other questions later. Thank you for watching.